Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 4 video on the chapter of integers where I will solve the problems of chapter concept test number 1 which is based on the review of integers from the chapter of integers. If you have not watched the previous part 1, part 2, part 3 videos on this chapter of integers, then I strongly suggest and request that you please watch those videos also to maintain the continuity of your study on the chapter of integers. So this video is part of the playlist ICSE Math 7 following the textbook of author M.L. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 4 video on the chapter of integers where I will solve the problems of chapter concept test number 1. Okay, so I have the chapter concept test number 1 on the left hand side. I hope the fonts are big enough so that you can see them. I will also attach the link of the PDF of this concept test number 1 in the description below of this video. Okay, so let's start solving the problem. So as you can see, section A, there are 3 sections, section A, B and C. All the sections have 5 questions. Section A are all single correct choice question. Section B are all fill in the blanks question, and section C are all true and false statement. Okay, let's start solving the problems. Question number 1, it is about simplifying the given numerical expression. So the numerical expression is minus 12 minus 7, and then we have plus 9 minus 10 plus minus 12 and minus 13. So whenever we have addition, this kind of numerical expression of integers where we have some addition and some subtraction operation, we first try to identify which are the addition and which are the subtraction operation. So in this case, this is the subtraction operation. We have this addition operation, we have this as subtraction operation, we have this as addition operation, and finally we have this as subtraction operation. So we can see there are 3 subtraction operation and 2 addition operation. Okay, so the first step is that we will convert all the subtraction operation to addition operation using the concept that subtracting b from a minus b is equal to a plus additive inverse of b, that is minus of b. Okay, so it becomes a minus of 12. Now minus of minus 7 will be plus additive inverse of minus 7, that is negative of negative 7, and then we have plus 9. Now again minus of 10, we will convert that to an addition operation as plus additive inverse of 10, that is minus 10, and then we have plus minus 12, and finally again we have minus 13, which is plus additive inverse of 13, that is minus of 13. So now we can see the entire numerical expression has been converted into a form where we have only addition operation. So this is now addition of more than 2 integers, where some integers are positive and some integers are negative. But before that, you can see that one integer is negative of 7. You must always simplify a negative of some number, that is negative of a is always equal to a. So let's simplify the second integer, that is negative of 7 will be 7. So we have 7, and then the rest of the numbers as it is. We have this. So now we will group all the negative integers in one place and all the positive integers in one place. So this will be and we'll put all the positive integers and the negative integers in separate brackets. So this becomes if I first group all the positive integers, this will be 7 plus 9, 7 plus 9, because these are only two positive integers and the rest all are negative integers. So let's group the negative integers in a separate bracket. We have minus 12 plus minus 10 plus minus 12 plus minus 13. Now if I do any kind of calculation mistake and come up with the wrong result or incorrect answer, please feel free to let me know in the comment section, because I am really it's a bad habit of mine that I am prone to make silly mistake. Okay, so 7 plus 9 is 16, and what will be the addition of all the negative integers? It will be a negative of the sum of all the absolute value of the negative integers. So 12, absolute value of minus 12 is 12, absolute value of minus 10 is 10. So like this we have 12 plus 10 plus 12 plus 13. Why? Okay, fine. So this is equal to 16 plus negative of I have to now inside the bracket we can see there are addition of four positive integers. So basically you will add them as whole numbers. So 12 plus 10 is 22, 22 plus, so you can add whole numbers or positive integers two at a time from the left hand side. So 12 plus 10 is 22, 22 plus 12 is 34, and 34 plus 13 is 47. So this is 47. So this becomes equals to 16 plus minus 47. So now we have to add two integers where one is negative and one is positive. Positive is 16 and the negative integer is minus 47. So we know that we subtract the numerically smaller integer from the numerically greater integer. In this case, the numerically smaller integer is 16 and the numerically greater integer is 47. So I will do 47 minus 16, and the sign that I have to put will be the sign of the numerically greater integer, which is the numerically greater integer is minus 47, because absolute value of minus 47 is 47 and absolute value of 16 is 16. So 47 is greater than 16. So the numerically greater integer is minus 47 and its sign is negative. So it will be minus. Okay. So this is equal to how much is 47 minus 16? It is 31. So this is minus 31. And I did a blunder. I forgot to put the choices. I forgot to put choices for the question number 1. So I'm really sorry for this. Anyway, I think I have not made there is no silly mistake or calculation mistake, and the answer and the simplified value of the expression should be minus 31. Okay, let's do the next problem. Question number 2. Question number 2 says that what integer value of p and q will make the value of the numerical expression. There is, as you can see, there are addition of two absolute terms. Now by absolute terms I mean that a numerical expression inside a absolute symbol, like, so this is absolute value of minus 9. So this expression is just an absolute this absolute operator, it has only one single integer inside it, but this one 4 plus minus 6, this you can say is an absolute term. Why? Because there is a numerical expression inside the absolute operator. By absolute operator I mean this absolute notation. Okay, so it is saying that what integer value of p and q will make the value of the numerical expression equal to additive identity. Now additive identity is 0. So it is saying that what will be the value of P and Q, so that absolute value of P minus 9 minus 1 plus absolute value of Q plus minus of P, this will be equal to 0. What integer value of P and Q will make the value of the numerical expression equal to additive identity, that is the value of the numerical expression will be equal to 0. So we have this equation. Now I have explained in my previous video that regarding absolute value, if you have something like this, that absolute value of x is equal to 0, this will always imply that x is equal to 0. Also, if you have something like absolute value of x plus absolute value of y is equal to 0, this will imply that both x and y are equal to 0. Now these x and y, they can be single integer or they can be some numerical expression. So if you have the addition of two or more terms having absolute terms, and the addition sum is given to be 0, then all the individual numerical expression inside the absolute notation, absolute operator, will be 0. So this equation, this will imply that P minus the numerical expression inside the first absolute operator is P minus minus of 9 minus 1. This should be equal to 0, and also the numerical expression inside the second absolute term will also be 0. So we must have Q plus minus P equals to 0. We have these two result or equation. Now from the equation 1, we can easily find out the value of P, because it is a linear equation in P. But before that, we have to properly simplify the LHS. So we have P minus 9 minus 1 is equal to 0. Okay. Now P minus of minus 9, this implies I can convert the P minus, the subtraction of minus 9 from P, as P plus the additive inverse of 9, that is negative 9, and also I can say okay, so minus 1 is equal to 0. Now I know that from this equation you can easily orally find out what will be the value of P, but since these concept test problems are based on the topic of review of integers, where I discussed about how we do addition and subtraction of integers, I'm trying to solve the problems in a detail with detailed steps. Okay, so this becomes now negative of 9 is 9. So we have P plus 9 minus 1 is equal to 0. Now this is a simple linear equation in one variable, which is P. I think you have already done a linear equation in one variable in class 6. I am not sure. If not, maybe definitely you will do it in class in this class. Anyway, so even if you are not aware of solving a linear equation in one variable, how will I find the value of P? Okay, so now this is P plus I can say this is P plus 9 minus 1 now is equal to 0. So this implies I can say this as P plus, I can do 9 minus 1 is, so I can say this is 9 minus 1 is equal to 0. So this implies P plus 9 minus 1 is 8, P plus 8 is equal to 0. So now this will implies P plus 8 is equal to 0, means that P is the additive inverse of 8. This implies that P is the additive inverse, AI means additive inverse of 8, which is equal to minus 8. So we have found that P is equal to minus 8 from the equation 1. p is equal to minus 8. Now in the equation 2, if we putting p is equal to minus 8 in 2, if that is in the equation 2, we get q plus this is minus of minus p, means p is minus 8, so minus of minus 8, this is equal to 0. Okay, this implies q plus negative of negative 8 means 8, so q plus 8 is equal to 0. So again we have q plus 8 is equal to 0. This means that q is equal to additive inverse of 8. We have studied regarding the additive inverse that of an integer x. If we have if x and y are additive inverse of each other, this will imply, we have seen, it will mean that x plus y is equal to 0. And the reverse is also true, that is the converse is also true. If for integer, two integer x and y, we have x plus y is equal to 0, this will mean that x and y are additive inverse of each other. Okay, so we have q is equal to additive inverse of 8, and additive inverse of 8 is minus 8. So the answer is the value of p and q will be p is equal to minus 8 and q is also equal to minus 8. So these are the values of p and q that will make the given numerical expression, its value will be equal to 0, that is additive identity means 0. So the correct choice is C. C is the correct choice. C is the correct choice. Okay, let's do question number 3. It says that two integers x and y are such that the predecessor of x is equal to the successor of y. Which of the following statements can never be true? The choices are both x and y are positive integers, both x and y are negative integers, distance between x and y on number line is 1, x and y are additive inverse of each other. Okay, now what can we understand, what can we say about the integer x and y when it is given that predecessor of x is equal to the successor of y. Okay, so predecessor of x, we know, is the number, is the integer which lies to the left hand side of the on the number line, left hand side of x on the number line. That is the predecessor of x, and x must be consecutive integer. So definitely the predecessor of x is nothing but x minus 1, one integer less than x. Okay, and the successor of y, what is successor of y? Successor of y is equal to y plus 1, that is the next integer to the right hand side of y on the number line. So it is given that predecessor of x is equal to the successor of y. So it means that x minus y is equal to y plus 1. Okay. Now, so this means that okay, I think it will be better understood instead of doing this kind of calculation. I think it will be better understood on the number line. I'm sorry, I will for the moment I will not use this concept, even though this is correct, that the predecessor of x is x minus y and successor of y is equal to y plus 1. But let's try to solve the problem in a different way. So it is let's try to understand the position of the integer x and y. So we have the number line. Let's say somewhere this is the point. Let's say this is the point marked by the letter x, so that its value is x, the integer x. So it is given that the predecessor of x, so the predecessor, let's say let's say we have let's say we have the integer marking like this. Okay, so the predecessor of x will be this. Predecessor of x will be this. Let's say this point be y, and the successor. So there are two integers x and y is equal, and the successor of y. So such that the predecessor of x is equal to the successor of y. Now let's say this point be z, that is the predecessor of x. Let's say that that value, so predecessor of x is nothing but x minus 1. The value integer is x minus 1, and let's say on the number line x minus 1 be marked by the letter z. Okay. Now it is also said that the predecessor of x, that is x minus 1, is equal to the successor of y. Now successor of y. Now if so definitely the success, so y has to be this point. This point has to be y. This point has to be y. Then only we can say that the successor of y on the number line, we can see the successor of y is x minus y, and also x minus 1, which is marked by the point z. And also we see that the predecessor of the integer x, which is marked by the point x, is x minus 1. So this is the scenario. This is the position of the integer x and y on the number line, which means that so definitely y is less than x. Y is less than x, and between y and x there is only one integer, which is x minus 1. Okay, now let's see the choice A. The question is asking that which of the following statements can never be true. We have to select the choice which can never be true. Let's see the choice A. Both x and y are now. So the problem did not. So we have understood that the integer y, between integer y is less than integer is x, and between y and x there is only one integer, which is x minus 1. But we do not know whether x and y are positive integers or x and y are negative integers. Exactly their position relative to the origin we do not know. Either they are positive, either they are negative. We have no information. We just know that between y and x there is one integer. There is one more integer, which is x minus 1, or you can say y plus 1. Okay. So choice A, both x and y are positive integers. Is it true that so can this be the answer, that x and y can never be positive integers? No, choice A cannot be the answer. The question is asking which of the following statements can never be true. Can never be true. So so can we say that x and y can never be positive integers? No, x and y can be. X and y, it is the values of x and y can be positive. Can be positive. They can both x and y can lie to the right hand side of the origin. They can also lie to the left hand side of the origin, because we only know that y is less than x. Y is less than x, and in fact there is only one integer between y and x. We have no other information whether y and x lie to the right hand side. They can both lie to the right hand side. They can both lie to the left hand side of the origin. So choice A and B are not the correct choices, because it is highly possible that both x and y can be negative integers. For example, y can be minus 3 and x can be minus 1. So this can be y, this can be y, and this can be x. And we have in between the number minus 2, which is z. So still, as you can see, that the successor of y is minus 2 and the predecessor of x is minus 2. But y and x are both negative. We can also have, similarly, we can also have 3 as y and 5 as x. And in between there is the integer, only one integer, 4, which let's say it is z. So here also we can see that the successor of y is 4, which is equal to the predecessor of the integer x, or 5. But both y and x, that is 3 and 5, are positive integers. So choice A and B are not correct choice. They cannot be the answer. Okay. Choice C, distance between x and y on number line is 1. So remember that the problem is asking which of the following statements can never be true. Can never be true. So let's find. So what is the distance between y and x? We don't know exactly what is the value of y and x, but can we find the value of, can we find the distance between y and x? We surely know that y is less than x, and but what will be the distance between y and x? We know that distance, from the formula, distance between y and x, where x is greater than y, is equal to x minus y, is equal to x minus y. And x minus y. Now if you see, now I think the concept that I started with, that predecessor of x is equal to x minus 1, successor of y is equal to y plus 1. So we have that x minus 1 is equal to y plus 1. So from here we can easily see that if I bring y to the left hand side, I will have, from here I can see that x minus y is equal to 1 plus 1, which is equal to 2. So so whatever the value of x and y be, they can take any values, but we know that y is less than x and there is only one integer between y and x. So this will imply that x minus y will this will imply that x minus y will always be equal to 2. So we will have distance between y and x is equal to x minus y. This will always be equal to 2. So the choice C, it will always be false. Choice C is saying that distance between x and y on number line is 1. No, the distance between x and y on the number line will always be 2. Will always be 2. So definitely the answer is choice C. Even though you can also check the choice D. Choice D says that x and y are additive inverse of each other. Now, so it means that, so is it true that x and y can never be additive inverse of each other? No, it is not true, because y can be minus 1 and x can be 1. This so this will also, in this case also, we will see that the successor of y is 0 and the predecessor of x is 0. But y and x minus 1 and 1 are additive inverse of each other. So it is highly possible that x and y are additive inverse of each other. So clearly the correct choice is C, that is the distance between x and y on the number line is 1. This can never be true. Okay, let's see the next question. Question number 4. It says that let a dx denotes the distance of an integer marked as x on the number line from the origin. If a is equal to minus 4, b is equal to minus 2 and c is equal to 3, then the value of absolute value of dA minus dB minus dC minus of dA is. So basically we have to find all the values of dA, dB and dC. Now, what is dx? What is the notation dA, dB, dC? So that is that notation is explained in the very first sentence, that dx denotes the distance of an integer marked as x on the number line. So if you consider this as the number line, let's say, and let's say we have point x. Let's say we have a point x, an integer value is marked on the number line with the point x, and let's say this be the origin, which refers to the integer value 0. So dx, and let's say the integer value which is marked by the letter x be small x. So it just means that dx is nothing but the distance of the integer value small x from the origin, which in this case, since I have drawn the letter x on the right hand side of O origin, definitely small x will be greater than 0. So this is equal to small x. Okay, so now let's see what will be A. Now remember, A, B, C, A and B are all negative integers. So let's say so let's try to draw let's try to represent, mark all the integer values A, B and C on the number line. So we have this number line, O is the origin, which refers to the integer value 0. So B is -2. Let's say this is the point, this is the integer -2, which is marked by the letter B, and let's say this is -4, integer -4 marked by A, and we have 3. Let's say this is 3 marked by C. So what will be dA? dA will be the distance of the integer value of A from the origin. This is equal to distance of -4 from origin, which is nothing but the distance is always a positive value. So this is nothing but the absolute value of -4, which is equal to 4. Also dB is equal to distance of the integer value -2 from origin. This will be absolute value of -2, which is equal to 2. And finally dC is distance of the integer value, since the value of C is 3, the distance of the integer value of 3 from origin, which is equal to absolute value of 3, which is equal to 3. So we know the value of dA, dB and dC. So now we have to find the value of the given numerical expression. So now absolute value of dA minus dB minus dC minus dA will be equal to, we just put the values of dA, dB and dC. dA was 4, minus dB was 2, minus dC is 3, minus dA is 4. So we have to evaluate this numerical expression. Now absolute value, so inside absolute value we have 4 minus 2, which is 2. So we have absolute value of 2 minus 3 minus of minus 4. This is equal to 2 minus 3 minus 4. So this is now numerical expression of addition and subtraction of 2 or more integers. So I will convert all the subtraction operation to addition operation, like 2 plus additive inverse of 3, that is minus 3. Again this will be plus additive inverse of minus 4. Okay, so this is 2 plus minus 3, negative of 4 is 4. So we have 4. So this I can write as 2 plus 4, 2 plus 4 plus minus 3. That is, I am grouping all the positive integers and the negative integers separately. So 2 plus 4 is 6. We have 6 plus minus 3. This is equal to positive of 6 minus 3, which is equal to 3. Oh, I again did a mistake. I forgot to give the choices, the values of the choices. I'm really sorry. This kind of mistakes is really not good. I will make sure that in future I do not make this kind of mistake, because it is really very embarrassing for you students to solve this kind of problem where there is no choices are blank. I'm really sorry. I hope I have not I did not do any kind of calculation mistake, and the given numerical expression, its value will be equal to 3. If you see any kind of calculation mistake, please feel free to let me know in the comment section. I will highly appreciate that. Okay, let's see question number 5. What is the least positive integer value of m that makes the following statement true? We have to find the least positive integer. Now, positive integers are integers greater than or equal to 1. Remember, 0 is not a positive integer. Positive integers are all integers greater than or equal to 1. So, what is the least value of m that will satisfy the given relation? The relation or the statement is negative of minus 15 plus minus 3 plus minus 3 plus m. This is greater than absolute value of 2 plus minus 8. Now, to solve this kind of problem, always try to simplify both the LHS and RHS as much as possible. That is, simplify addition of some integers or addition subtraction of integers as much as possible. So, definitely we can easily find the value of the RHS and some part of the LHS. Okay, let's try to simplify the part of the LHS that we can which are having constant which are having integers. Okay, so let's simplify. Okay, so now it is minus 15. This thing is nothing but negative of 15, which is 15, and we have minus 3 plus minus 3 plus m greater than what will be the value of the numerical expression inside the absolute notation. It is 2 plus minus 8. 2 plus minus 8. So it will be we have 2 plus minus 8 means addition of one negative and one positive. So this will be definitely 8 minus 2, negative of 8 minus 2. Why? Because 2 plus minus 8 numerically between 2 and minus 8 numerically greater integer is minus 8. So it will be 8 minus 2, and the sign will be the sign of the numerically greater integer, which in this case is minus 8. Minus 8 is numerically greater than 2, and the sign of minus 8 is minus. So we have this. Okay. Now let's see on the left hand side. I will so 15 minus 3. I will convert the subtraction operation as addition operation. So this will be 15 plus negative of 3, and I have plus negative of 3 plus m greater than so it becomes absolute value of 8 minus 2 is 6. So this becomes absolute value of minus 6. Now so I have to now do 15 plus negative of 3 plus negative of 3. So this is I will group the negative terms, minus 3 plus minus 3, and then I have plus 15, and I have plus m greater than absolute value of minus 6 is 6. I have this. Now this implies what is negative of minus 3 plus minus 3. It is minus of 3 plus 3. and I have plus 15 plus m greater than 6. So this implies 3 plus 3 is 6 minus 6 plus 15 plus m is greater than 6. This implies how much is minus 6 and plus 15? It is 15 minus 6 plus m is greater than 6. This implies 15 minus 6 is 9. So we have 9 plus m greater than 6. Now I can subtract in this kind of inequality where you have something like x plus a greater than y, let's say, where a is some known constant, a is some known integer. I can subtract any known constant from both the LHS and RHS of this inequality. I can add or subtract. So I can say this will be equal to x plus a. I am subtracting the constant a from both the side. A will be equal to greater than 1 minus y minus a. So this implies x will be greater than y minus a. So from the fact that x plus a is greater than y, I can say that x is greater than y minus a. You can also think of like this. I have transposed a to the right hand side. In an equation, whether it be equality or inequality, when you transpose, that is when you shift one term from one side to the other, in this case, if I want to shift a, which is on the left hand side, if I want to shift a to the right hand side, the sign will change. On the left hand side, the sign is plus a. So on the right hand side, when I will shift a to the right hand side, it will become minus a. So you see x is greater than y minus a. So I can shift the 9 to the right, from the left hand side to the right hand side, and it will be y m will be greater than 6, but in the sign of 9 will change. It will be 6 minus 9. So this implies m is greater than 6 minus 9. 6 minus 9 is minus 3. 6 minus 9 is minus 3. So we got that m is greater than minus 3. Now since m is an integer, definitely now m is greater than minus 3 means that this implies that the value of m can be greater than or equal to minus 2. Now the problem is asking what is the least positive integer value of m that makes the following statement true. So to satisfy the given inequality, the value of m has to be greater than or equals to minus 2. This implies, but the problem is asking what is the least positive integer value of m that will satisfy the given equality. So this means that least positive integer value will definitely be 1, because even though we know that m can take any value greater than or equals to minus 2, that is the value of m can be minus 2, minus 1, 0, 1, 2, 3, 4 like this. But the problem is asking what will be the least positive integer. So the least positive integer, we know that positive integer starts from 1. So the least positive integer that will satisfy the fact that m has to be greater than or equals to minus 2 has to be 1. So the least positive integer value of m is equal to 1, and hence the correct choice is A. A is the correct choice. Okay, so this comes to an end of section A, which were multiple choice problems where only one choice will be correct. Let's do section B. Question number 6. These are fill in the blanks question. Okay. Question number 6. If P is the least non-negative integer and Q is the largest negative integer, then the additive inverse of P minus Q is. So P is the P is equal to, is given least positive, least non-negative integer, Now what are non-negative integers? Non-negative integers are integers which are not negative, which means the integers which are not negative are 0, 1, 2, 3, 4 like this. So the least non-negative integer has to be 0. The non-negative integers are all the integers which are not negative. That means it can have the value 0, because we know that 0 is neither positive nor negative. So 0 is not a negative number, so it has to be a non-negative integer, and all the positive integers. So all non-negative integers are 0, 1, 2, 3, 4, 5 like this, and the least of the non-negative integers is obviously 0. So P is 0. Okay. What is Q? Q is the largest negative integer. So we know that largest negative integer is, we know that is -1, because to the left hand side of the origin we have all the negative integers, and as we progress to the left hand side towards left, we visit smaller integer, smaller negative values. So definitely the largest negative integer is -1. So we now know that P is 0 and Q is 1. Q is -1. So this implies it is asking what will be the additive inverse of P minus Q. So let's first find what is P minus of Q. This is equal to Q. P is 0 minus minus of Q, that is this. Q is, remember, Q is -1. So we have this. Now this is 0 minus inside the parenthesis we have negative of -1, negative of 1, which is 1. So we have 1, and this is obviously equal to -1. So the value of P minus Q is equal to 1. So this implies additive inverse of P minus Q is equal to additive inverse of -1, which is equal to minus of -1, or this is equal to 1. Okay. Let's do question number 7. The sum of all integers between -6 and 3 is equal to. So we have to find, we have to first figure it out, what are the integers between -6 and 3, and we have to find the sum of them. So integers between -6 and 3 are, we have -5, -4, -3, -2, -1, 0, 1 and 2. So these are the integers between -6 and 3. So we have to add them. So we have to find -5 plus -4 plus -3 plus -2 plus -1. 0 we did not add, we have 1 plus 2. Now in this kind of numerical expression of addition and subtraction, since in this numerical expression we are having all addition operation, we will see if there are two integers which are additive inverse of each other, then we can cancel them out, and we see that there is -2 and 2. The last integer is 2 and there is also -2, so I can cancel these two integers in the sum. So this will be -5 plus -4 plus -3 plus, and also we can see there are integers 1 and -1, so they will also cancel out. Okay, so we have this. we have this. So now this is addition of three negative integers, that is -5, -4 and -3. So this will be obviously negative of 5 plus 4 plus 3, which is equal to 5 plus 4 plus 3 is 12. So this is minus 12. So the answer is the sum is equal to minus 12. Okay. Let's do question number 8. For a positive integer n, if the distance between n and its additive inverse on the number line is 10, then what will be the value of absolute value of minus n plus 3? For a positive integer n, if the distance between n and its additive inverse on the number line is 10. Okay. So let's try to visualize what is happening. So we have the number line and we have the origin, let's say O. This represents the value 0. It is said that the n is a positive integer. So definitely it will lie on the number line to the right hand side of origin. Let's say this be n. Let's say this be n. Okay. So for a positive integer n, if the distance between n and its additive inverse. Now if let's say what will be let's say so for a positive integer n, so let's not mark it with n, the value of so let's say the positive integer n is marked by the point A. Now what will be what is the additive inverse of the positive integer n? Additive inverse of n is minus n. So definitely it will be on the number line, minus n will be somewhere here. This is minus n. Let minus n be marked by the point B. So the integer values marked by point A and B are additive inverse of each other. That is, one is n, which is a positive integer, and its additive inverse is minus n, which will definitely be a negative integer. Now it is given that the distance between n, that is the distance between the integer n and minus n, is 10. Now what is the distance? Distance between B, which is the integer minus n, and the point A, which is represents the integer n, will be equal to n minus n. We have discussed in the previous video regarding the distance between two integers. If we have two integers, x and y, where x is less than y, then our distance between x and y is equal to y minus x. So the distance between minus n and n, where definitely minus n is less than n, will be n minus of n. So this is equal to, I can say clearly this is equal to n positive. So this is n, we are subtracting minus n from n, which means I can convert the subtraction operation as addition operation as n plus negative of negative n. So this is n plus negative of n is n. So this is n plus n. Obviously this is twice n. So the distance between the positive integer n and its additive inverse is twice n, which is given to be 10. So this implies that twice n is equal to 10. So this implies that n is equal to 10 by 2, which is equal to 5. So the value of the positive integer n is 5. So now what will be the value of minus of n plus 3? This is equal to absolute value of n is 5. So minus 5 plus 3. To find the value of absolute value of minus 5 plus 3, we have to first find the numerical value inside the absolute notation. So first we have to find what is minus 5 plus 3. So minus 5 plus 3 obviously will be negative of 5 minus 3, because we are minus 5 plus 3 means we are adding one negative integer which is minus 5 and one positive integer 3. So we will subtract the numerically smaller value integer from the numerically larger integer. Here numerically larger integer is 5 and numerically smaller integer is 3. So we will find 5 minus 3. Now we have to put the sign. The sign will be the sign of the numerically greater integer. Between minus 5 and 3, the numerically greater integer is minus 5. So its sign we will put negative. So this is equal to absolute value of 5 minus 3 is 2. This is absolute value of minus 2. This is 2. So the value of the given expression, that is absolute value of minus 3 minus n plus 3 will be 2, as we have found the value of n to be 5. Okay, let's do question number 9. L is a negative integer. L is a negative integer. If small a is equal to minus L plus 1, b is equal to absolute value of L, and c is equal to 1 plus L, then the ascending order of a, b and c is. So L is a negative integer. So on the number line, let's say this with the origin O that represents the value integer value 0 somewhere here is L. Let's say L is a negative integer. This is L. Remember, L is a negative integer. Let's say this be marked by the point A. Now, so we have L is a negative integer. Okay, L is less than 0. Now, let's see what will be the values of what will be. So what are A, B and C? A is equal to minus L plus 1. Now this is so this is equal to minus of L plus 1. Now what will be minus of L plus 1? Where will we are trying to figure it out where on the number line where what will be the position of the integers a, b and c based on the given fact that a is equal to minus L plus 1, b is equal to absolute value of L, and c is equal to 1 plus L, where L is a negative integer. Now I think where L is a negative integer. Okay. Now, okay, so A is minus of L plus 1. Now, where will A be on the number line? I think it will be better if we say, since L is a negative integer, let's say let L is equal to minus x, where x is a positive integer, that is x is a greater than, x is an integer which is greater than 0, then obviously minus x will be a negative integer. So L we are having, then we will have this as the minus x will be somewhere here. Now if the position of minus x is marked by the point A on the number line, definitely what will be minus L. So A is negative of L plus 1. Now we have assumed that L to be minus x. Since L is given to be a negative integer, we are assuming that L to be a minus of x, where for some positive integer x. So if x is a positive integer, definitely minus x will be a negative integer. So this is now negative of what is L? L is minus x. This is this. Negative of x is x plus 1. So A will be x plus 1. Now where will x be? X is the additive inverse of minus x. So x will be somewhere here. The point B will be represent the value x, and definitely the next integer, the next consecutive integer, or the what is x plus 1? X plus 1 is the successor of x. So let's say this be x plus 1, x plus 1. So a is let's say so this will be equal to a. On the number line we can see that a is lying to the right hand side of the point B, where point B is represented the value x, where we have assumed that L to be equal to minus x. Okay. So based on the position, if we can correctly position the integer values, the values of a, b and c on the number line, then also we can figure it out what will be the ascending order. Okay. Now what is b? B is equal to absolute value of L. This is equal to absolute value of minus x, as we have assumed L to be equal to minus x. Now what is absolute value of minus x? This is equal to absolute value of x. This is equal to x, because when we have assumed L to be minus x, definitely x will be a positive integer, and for a positive integer x, its absolute value will be equal to x. So if x is positive, then absolute value of x is equal to x. So where is x? So what is b? B is, so x is here. So small b is nothing but, on the number line, small b is marked by the point B. So this is also B. Okay. Now let's see what will be C. C is equal to 1 plus L. 1 plus L. This is equal to, what is L? L is minus x. Okay. So this is equal to minus x plus 1. Now minus x plus 1 means it is the successor of x. Minus x plus 1 is successor of x. So this is equal to successor of minus x. So so this point will be minus x plus 1. So let's say this point, the marked by the letter C. So we have let's say this point, the point x plus 1, which is equal to a, b, d, and the point C is marking the value C, which is equal to minus x plus 1. Okay. So we can clearly see the position of ABC. ABC. Now if I just draw, since the number line has become clumsy, if I just draw the position of A, B and C, this is the origin O, which represents the value 0. We have here the letter C is marking the value, is marking the integer small c, and we have this is C is small c is being marked by the capital letter C to the left hand side of the origin O, and B is being marked by the point by the letter B, which is to the right hand side of the origin O, and A is being marked by the point D, which is to the right hand side of the point B, A. So clearly we can say, this implies, if we have to arrange the values A, B and C, it will be C is less than B is less than A. So this is the since we have to arrange A, B and C in the ascending order, so definitely this will be the ascending order. Okay, let's do question number 10. It is given A is given to be a numerical expression, B is also given to be a numerical expression, then we have to find minus B minus A. So we have to first find the values of A and B. So A is minus 12, we have plus minus 9, we have plus 6, and then minus 2. So clearly this is minus 12 plus minus 9 plus 6 minus of minus 2. We can see that there are two addition operation, these two are addition operation and one subtraction operation. We will convert the subtraction operation to addition operation, and it becomes minus 12 plus minus 9 plus 6 plus negative of minus 2 or additive inverse of minus 2. So this is minus 12 plus minus 9 plus 6 plus negative of minus 2. Negative of 2 is 2. We know that for any integer x, negative of negative x is equal to always x. So now we have addition of integers. We have all addition operation where we are adding more than two integers, where some integers are negative and some integers are positive. So we will group them as negative integers and we will separately add the negative integers and the positive integers. So we have minus 12 plus minus 9 and then we add 6 plus 2. So minus 12 plus minus 9, the addition of minus 12 and minus 9, that is both are negative integers, will be negative of 12 plus 9, and we have 6 plus 2 is 8. This is equal to 12 plus 9 is 21. So this is minus 21 plus 8. So we are adding one negative and one positive integer, and we can clearly see the numerically greater integer is minus 21. So it will be minus of 21 minus 8, which is equal to a minus of 13. So minus 13 is okay. So A is minus 13. Sorry, A is minus 13. Okay, what is B? B is absolute value of minus 15 plus 9. Now, how much is minus 15 plus 9? Minus 15, the two integers we are adding is minus 15 and plus 9. So this is minus 15. We are adding minus 15 and 9. And between minus 15 and 9, the numerically greater integer is 15. So it will be 15 minus 9 and negative sign, because minus 15 is numerically greater integer. Okay, so this is absolute value of 15 minus 9 is 6. Absolute value of minus 6, this is equal to 6. So value of B is 6 and value of A is minus 13. So this implies negative of B minus A will be equal to B is 6. So negative of 6 minus A is minus 13. So this is minus 6, and this is we are subtracting minus 13 from minus 6. So this means we will add negative additive inverse of minus 13, that is negative of minus 13. This is minus 6 plus negative of 13 is 13. So now we have to add minus 6 and 13, and the numerically greater integer is 13. So it will be plus 13 minus 6, which is equal to 7. So the value of the answer will be 7. Okay. So this with this we come it comes to an end of the section B, which were fill in the blanks problem. Let's do the section C, which are true false statement. We have to identify whether the given statements are true or false. Question number 11. If minus x and y are additive inverse of each other, then it is saying that negative of x plus y is equal to 0. We know that if minus x means this and y are given are additive inverse of each other, this will imply that we must have the sum of an integer and its additive inverse is always equal to 0. So we must have minus of x plus y is equal to 0. That is, if two integers x and y, they are additive inverse of each other, we must have x plus y is equal to 0. In this problem, it is given minus x and y are additive inverse of each other. So we must have minus x plus y is equal to 0. This implies that we are having we are having y minus x plus y minus x plus y is nothing but y minus x is 0. So definitely we cannot say that negative of x plus y is 0. We can say from the fact that minus x and y are additive inverse of each other, we can say that y minus x is equal to 0. But this does not imply that negative of x plus y will be equal to 0, and hence this is a false statement. Okay, question number 12. For an integer m, we always have absolute value of m greater than m. This is a false statement because false, as absolute value of 0, let's say as a counter example, if you consider the m to be the integer 0, for m equal to 0, absolute value of m is equal to absolute value of 0, which we know is equal to 0. And so this implies that, and we know that 0 is not is not greater than 0. 0 is never greater than 0. I mean, any integer is never greater than itself. And for if m is equal to 0, we can see that the absolute value of m and m, they are both 0. So this statement is false, because for m is equal to 0, this is not true. In fact, for all non-negative integers of m, for all non-negative values of m, this will be false. This will be false. That is, for all non-negative integers, that is all integers greater than equal to 0, this statement will be false. That is, absolute value of m greater than m will be false. For all non-negative integers m, absolute value of m is greater than m is incorrect. The statement absolute value of m is greater than m will only be true for negative values of negative integers. If m is negative, then only we can say absolute value of m is greater than m. So this is a false statement. Question number 13. Okay, so one equation is given related to absolute terms. So we have absolute value of m plus negative of -6 and plus absolute value of n plus -9 minus 3 is equal to 0. Now let's first simplify the expression inside the absolute operator as much as we can. So this is m, absolute value of m, negative of 6 is 6. So we have m plus 6, absolute value of m plus 6, and then we have n. Let's try to simplify. What will be minus 9 plus we have -9 minus 3. Okay, this is equal to 0. Okay, so this implies absolute value of m plus 6. Let's try to simplify the value of -9 minus 3. So this will be n plus -9 minus 3 can be converted into addition operation as plus negative of 3. We have 0. Okay. Now let's further simplify the second term of the second absolute term. So we have what will be, so this is n plus minus 9 plus minus 3 is nothing but negative of 9 plus 3. We have this is equal to 0. This implies absolute value of m plus 6 and absolute value of 9 plus 3 is 12. So we have n plus minus 12 is equal to 0. Now when we know that the sum of, if it is given that the sum of some absolute terms are is 0, then all the numerical expression inside the absolute terms will be equal to 0. So if we have, let's say, absolute value of x plus absolute value of y is equal to 0, where x and y, they could be single integer or they could be some numerical expression. So this will imply that x will be 0 as well as y will be equal to 0. So we can now say that m plus 6 is 0. This implies that if m plus 6 is 0, we must have m and 6 to be additive inverse of each other. So which means that m is additive inverse is equal to additive inverse of 6, which is equal to minus 6. So m is 6. Also we will have n plus minus 12 is equal to 0. So this implies that n will be equal to additive inverse of minus 12, which is equal to additive inverse of minus 12 is negative of minus 12, which is equal to 12. So n is equal to 12 and m is equal to minus 6. Now we can find the value of we need to find the value of absolute value of minus n plus m is equal to, what is n? N was 12. So we have minus 12 plus m is minus 6. So this is equal to, inside the absolute notation we have minus 12 plus minus 6. This will be minus 12 plus 6. And this is absolute value of 12 plus 6 is 18. So we have absolute value of minus 18, which is equal to 18. So we are having the value to be 18, and it is given that it is saying that absolute value of minus n plus m is 0. So this is a false statement. So this is a false statement. Okay. Let's do question number 14. If r minus s is equal to 0, then minus r and minus s are additive inverse of each other. Okay. Now what is given? It is given that r minus negative of s is equal to 0. The LHS is what is LHS? LHS is we are subtracting minus s from r. So this will be equal to r plus negative of minus s, which is this, is equal to 0. So this implies r plus negative of negative s is s. So we have r plus s equal to 0. So this, from here we can say that r and s are additive inverse of each other, additive inverse of each other. Now the statement is saying that minus r and minus s are additive inverse of each other. Is it true? If we know that r and s are additive inverse of each other, can we say negative of r and negative of s are additive inverse of each other? Yes, it is true. This will always imply, this is also another good concept, that if two integers r and s, if they are additive inverse of each other, this this will also imply that the negative of r and the negative of s will also be additive inverse of each other. This will imply negative of s and negative of r and negative of s are additive inverse of each other. Why? Why? Because we know that if r and s are additive inverse of each other, we will have r plus s is equal to 0. Now, if a negative of r and negative of s are the additive inverse of each other, we must have their sum to be equal to 0. That is, minus of r plus minus of s must be equal to 0. Now, what is negative of r plus negative of s? This is the negative of r plus negative of s is negative of r plus s. So, this is equal to 0, and this is a true statement, because if r plus s is equal to 0, because we know that r and s are additive inverse of each other, we already know that r plus s will be equal to 0. So, if r plus s is equal to 0, definitely negative of r plus s will also be 0. So, we can say that minus r and minus s are also additive inverse of each other. So, this is a true statement. Okay. Question number 15. Okay, so there is a greater than operator. It is saying that the left hand side is greater than the right hand side, where both LHS and RHS are absolute terms. By absolute term, I mean some numerical expression inside the absolute operator. Now, please note that to solve this problem, we don't even need to simplify the numerical expression inside each of the absolute notation. Why? Because we know that for any integer x, mod of x is always a non-negative integer. That is, it will always be greater than or equal to 0. And this implies that so it is true that for any integer x, mod x or absolute value of x will be always a non-negative integer. That is, its value will be either 0 or greater than 0. So, now if I put a negative sign in front of absolute value of x, this will be always greater than, mind it, greater than, less than 0, which means that negative of absolute value of x will be a non-positive integer. What is a non-positive integer? A non-positive integer is an integer which is not positive. So, which integers are not positive? 0 is not positive, and also all negative integers are not positive. So, all integers which are less than or equal to 0 are non-positive integers. So, if we have, so for any integer x, the negative of absolute value of x will always be less than or equal to 0. Now, let's see. Now, okay. So whatever the numerical expression be inside the absolute operator on both the sides, we can never have something like this, that is negative of absolute value of x is greater than absolute value of y, where let's say x and y are some integers. Whatever integers x and y are, irrespective of whether they are negative or positive, we can, or 0 or even 0, you can, for any value of x and y, let's say they are integers, we can never have negative of absolute value of x is greater than absolute value of y, because absolute value of y will always be a positive integer, will always be a non-negative integer, that is, it will be greater than or equal to 0, and negative of absolute value of x will always be a non-positive integer, that is less than or equal to 0. So, negative value of x, negative of absolute value of x can never be greater than absolute value of y for any you will not find any value of x and y such that absolute value, negative of absolute value of x will be greater than absolute value of y. So we can directly say that this will always be a false statement. Now you can you can find the value of the LHS and RHS, but that will be redundant. It will be a waste of time. So let's say if I want to find the evaluate if I want to find the value of the LHS and RHS and then verify whether the LHS is greater than RHS or not. So LHS is equal to negative of minus 2 plus 4 minus 6. This is negative of absolute value of minus 2 plus 4. So this is minus 2 plus 4 minus 6. Let's convert minus 6 to addition operation. So this will be plus minus 6. We have this. So this is now negative of, inside the absolute operator we are having addition of 3 integers where 2 are negative. So we can say this is equal to 4 plus minus 2 plus minus 6. That is, we will separately add the negative integers and the positive integer. So this is equal to negative of 4 plus, how much is minus 2 plus minus 6? It will be minus of 2 plus 6. Okay, this is equal to negative of absolute value of 4 plus 2 plus 6 is 8. So this is 4 plus minus 8. This is again is equal to negative of absolute value of 4 plus minus 8 is minus of 8 minus 4. This is equal to negative of absolute value of minus 4. This is equal to minus 4. So you see that the LHS is minus 4 and the RHS. So you see that LHS is minus 4 and the RHS can never be, RHS is an absolute value. Absolute value is always greater than or equal to 0. So we can never have that minus 4 is greater than some integer which is greater than or equal to 0. So this is the idea. So with this, it comes to an end in solving the problems of chapter concept test number 1. All the problems in this test number 1 were based on the videos that I have discussed on a review of integers, where I have discussed about addition, subtraction of integers, additive inverse of integer, absolute value of integer, and how to simplify numerical expression of addition and subtraction of negative or positive integers. I hope this video will be beneficial to clarify your doubts or concepts and how to apply the concepts to solve this kind of problems. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Okay, so in the next topic of the video, I will discuss about the properties of addition and subtraction of integers, and then after that I will solve the next problems of the next exercise, that is exercise 1.2. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.